So I grew up in South East London and I was really interested in astronomy, being close to the Royal Observatory in Greenwich. When I got older, I was fortunate to have a physics teacher who offered me to study astronomy GCSE in my lunch break with a few other students, and we really got engaged in astronomy and fascinated by how stars were formed, and that really inspired me to think about studying physics because I thought I would go on to pursue a career in astrophysics. When I came to Cambridge to study natural sciences, I took a bit of a detour away from astrophysics and towards the medical world after studying materials science in my first year at university. I wasn't actually very engaged with materials science, it was my least favourite course, but there was an element where there were some lectures on biomedicine, particularly hip implants and the materials that could be used to prolong people's mobility by providing hip replacements. And that really inspired me to think about how physical sciences could impact everyday life and set me on a path towards medical physics. My team work on imaging, and we're particularly interested in using our imaging technologies for the detection of early cancer. That's a really important problem because if we detect cancer at an earlier stage, we have a much higher chance of making a curative intervention. The sorts of things we do are use technologies that can be applied, for example, in endoscopy, where you can pass a camera down inside the body and look at disease at the early stages, or using hybrid modalities where we couple things like light and sound together to penetrate deeper into the tissue and look at the earliest signs of cancer emerging. We have to combine all of these imaging technologies with advanced computational analysis and machine learning, and we are very keen on translating our research, often then in first-in-human clinical trials or in translational models that allow us to test how the imaging signals that we measure collect to the underpinning biology. Well, if we take the example of endoscopy again, there are millions of procedures that are conducted throughout the world every year. But we know that those procedures that are targeted towards early cancer detection can often have high miss rates. Up to even 50% of endoscopies can miss the earliest signs of cancer. If we can improve the contrast for the clinicians who are operating those endoscopes so that those early signs of disease pop out with greater precision and are much easier to spot, then we have the potential to improve cancer survival rates.